Okay, so this is the key to the worksheet extra 8, topic 21 on radicals. And on this worksheet, you are asked to add or subtract radicals. Now, keep in mind that when adding or subtracting radicals, you have to make sure that you simplify the radicals as much as possible in order to be able to combine like terms. So let's look at number 1. So number 1, you have negative 12 square root of 5 plus 2 square root of 5 minus 3 square root of 5. So you have these three terms. And notice that all these three terms are like terms. Okay, so remember I'm using the word like terms. And they're like terms because they have the same index, square root, square root, square root. So the index is 2. All right, so the square root, there's no index there, so it's going to be 2. And they have the same radicands. So therefore I have negative 12 square root of 5, and then 2 square root of 5, so that's a negative 10. And the negative 10 square root of 5 and a negative 3 square root of 5 gives us a negative 13 square root of 5. So number 1, the answer is negative 13 square root of 5. All right, so number 2, we have the square root of 7 minus 4 square root of 7. So again, this is an easy one because, first of all, you cannot simplify the square root of 7 any further. The only perfect square that goes into 7 is 1. But notice that there's no number there right here. That's understood to be a 1. So you have 1 square root of 7 and a negative 4 square root of 7. So 1 and a negative 4 is a negative 3 square root of 7. So that's number 2. And number 3, you have 10 square root of 3 minus 4 square root of 7 minus 6 square root of 3 plus 9 square root of 7. And so in terms of simplifying these square roots of these radicals, you cannot do that any further. The only perfect squares that go to 3, 7, 3, and 7 is 1. Now, you have 4 terms here. 1, 2, 3, 4. So let's look at the square root of 3. So the square root of 3, so this term right here and this term right here are like terms because those two terms that have arrows pointing to, they have the same index and the same radicand. So 10 square root of 3 and a negative 6 square root of 3 is 4 square root of 3. And then if you look at the square root of 7s, you have a negative 4 and a positive 9. So that's a positive 5 square root of 7. So that's the answer for that one. Now those are not like terms because even though they have the same index, the radicands are different. Okay, so number 4, we have 12 square root of 5 and a negative 8 square root of 125. Now again, you have to make sure that the radicals are simplified because right now you notice that these, the way they look, the radicands are different. So you must simplify in order to be able to see if you can have the same radicand, get the same radicand. The indices are the same. They're both 2's, square roots, but the radicands look different. All right, so notice that I cannot simplify the square root of 5 because the only perfect square that goes into 5 is 1. But I can simplify the square root of 125. So what I would do is rather than doing all the work around here, go off to the side. Do work on the side. So you have the square root of 125. We know that the largest perfect square that goes into 125 is 25. So I can write this as a square root of 25 times and then the square root of 5. All right, now the square root of 25 is 5. 25 is a perfect square. 5 times 5 is 25. So this right here becomes this. So I'm going to replace this with this. So this becomes 12 square root of 5 minus 8 times 5 square root of 5. And so 8 times 5 is 40. So that becomes 12 square root of 5 minus 40 square root of 5. So you gotta go as far as you can. And now notice that at this point, these radicals are the same, and so therefore 12 square root of 5 and a negative 40 square root of 5 is a negative 28 square root of 5. All right, so that's number 4. And number 5, you have, let's see, that was number, I'm sorry, let me see, that was number 1, number 2, number 3, okay, this was number 5 right here, sorry. Okay, this is going to be number 4. So number 4, we have 4 square root of 13 plus the square root of 5 minus 3 square root of 5. So notice that in these three terms, they're simplified. The only perfect squares that go into 13, 5 is 1. But the only two terms that are like terms are these two. So these two are the only like terms. So I have 1 square root of 5 here and have a negative 3. So this right here becomes 4 square root of 13 minus 2 square root of 5. All right, so a 1 and a negative 3 is a negative 2. Now, if you want, you can write this as negative 2 square root of 5 plus 4 square root of 13. It does not matter because addition is commutative. All right, so that's number 4. So we did number 5. Now let's look at number 6. Number 6, you have the square root of 27 plus the square root of 108. All right, so notice that I can simplify each of those. So let's think about the square root of 27. So the square root of 27 is the square root of 9 times the square root of 3. And the square root of 9 is 3, so this becomes 3 square root of 3. So that goes here. So that's going to equal 3 square root of 3. Now let's think about 108. So the square root of 108 is what we're looking at now. So just try some perfect squares. So other than the smallest perfect square is 1. The next one is 4. So let's divide 108 divided by 4 and see what we get. We get 27. So 4 is a perfect square. 27, there's also another perfect square that goes into 27, and that's 9. So 4 times 9 is 36. So let's divide 108 divided by 36. So 108 divided by 36 gives us 3. So 36 is the largest perfect square. Not 4, not 9, but 36. So this becomes the square root of 36 times the square root of 3. And then the square root of 36 is 6, so I get 6 square root of 3. So that's going to go here. Okay? So the square root of 180 is 6 square root of 3. Now, I just want to remind you about something. So if you did use, let's say, 4. So you have the square root of 4 times the square root of 27. Okay? And that is the square root of 108. Because 4 times 27 is 108. So this is 2, but I can simplify this further because you can see there's a 9 here that will go into 27. So square root of 9, square root of 3, so you get 2 times 3, square root of 3, so you get 6 square root of 3. So even if you don't use the largest, you simplify as far as you can, you'll get the same answer in the end. So now these are like terms, so 3 and 6 is 9, so I get 9 square root of 3. So that's number 6. Let's look at number 7. At number 7, you have, let's see. All right, number 7, you have 5 square root of 32 minus 7 square root of 2. All right, so the square root of 2 I cannot simplify further, but I can simplify the square root of 32. So the square root of 32 will be the square root of 16 times the square root of 2. And the square root of 16 is 4, so you get 4 square root of 2. So that is this right here, but that's being multiplied by 5. So you get 5 times 4 square root of 2 minus 7 square root of 2. And 5 times 4 is 20, so you get 20 square root of 2 minus 7 square root of 2. And so now these are like terms. They both have square root of 2's in them. So 20 subtract 7 is 13. So you get 13 square root of 2. Number 8, you have 5 square root of 63 plus the square root of 112. So let's think about the square root of 63. So the square root of 63, I know, is the square root of 9 times the square root of 7. Because 9 is the largest perfect square that goes in 63. Square root of 9 is 3, so this is 3 square root of 7. So this becomes, don't forget, that's being multiplied by 5. So that's 5 times 3 square root of 7. Plus, now let's talk about the square root of 112. Let's talk about 4 again. Let's see if 4 goes in 112. So 112 divided by 4 gives us 28. But notice that another perfect square that goes into 28 is 4. So 4 times 4 is 16. So let's divide 112 divided by 16 now. And so there you go. So 16 is the largest perfect square. So the square root of 16 times the square root of 7. And the square root of 16 is 4. So you get 4 square root of 7. So that part is this, 4 square root of 7. Simplifying this further, 5 times 3 is 15. So you get 15 square root of 7 plus 4 square root of 7. So these are now like terms. They both have square root of 7s. 15 plus 4 is 19 square root of 7. Okay, number 9, you have the square root of 48 minus the square root of 108 plus the square root of 12. So now you have three radicals. You can simplify each of those because there's a perfect square that goes to each of those other than one. So if you look at the square root of 48, that's going to be the square root of 16 times the square root of 3. 16 times 3 is 48. Square root of 16 is 4, so you get 4 square root of 3. So that's this one. Okay, 108, I think we've already done, maybe not. So the square root of 108. So let's divide by 4, see if 108 is divisible by 4. And it is. And then notice 9 again right here. So 4 times 9 is 36. So it becomes the square root of 36 times the square root of, what's that, 3. Okay, and the square root of 36 is 6, so it's 6 square root of 3. So that's this one. And then 12, I'm going to go ahead and put that right here. Square root of 12 is the square root of 4 to the square root of 3. 4 times 3 is 12, so that's 2 square root of 3. And now notice those are all like terms. They all have the square root of 3's in them. So 4 and a negative 6 is a negative 2, and a negative 2 and a positive 2 is 0. So that's just 0. Okay, number 10. Number 10, you have 2 square root of 18 minus the square root of 128 plus 7 square root of 32. All right, so let's talk about the square root of 18. So the square root of 18, we know the largest perfect square goes with 18 is 9, so that's square root of 9 times square root of 2. So that's 3 square root of 2. So that's going to be 2 times 3 square root of 2. All right, 128. Let's talk about 128, the square root of 128. Let's try 4 again. So 128 divided by 4. 4 is a perfect square. Let's see what we get. We get 32. Now we know that 16 goes into 32. So 16 times 4, that should be the largest perfect square. All right, so let's see, 128 divided by 64 gives us 2. Okay, so that's going to be the square root of 64 times the square root of 2. The square root of 64 is 8. Right, so I get 8 square root of 2. So that's going to go here. And then plus 7 times, and then let's talk about the square root of 32. So the square root of 32, that's going to be the square root of 16 times the square root of 2. The square root of 16 is 4, so I get 4 square root of 2. So it's 7 times 4 square root of 2. Going further, 2 times 3 is 6, so I get 6 square root of 2, minus 8 square root of 2, plus, and then 7 times 4 is 28 square root of 2. And I notice that all these three terms are like terms, so on your calculator, just add these numbers together. You're going to say 6 and a negative 8, 6 plus a negative 8 plus, and then a positive 28 gives us 26. So this becomes 26 square root of 2. All right, so that is the key to the worksheet 8 on topic 21.